Talk he related at Oxford, which is on his YouTube channel. I saw the whole talk is going 1 hour long.
Oh, yeah, please. That's great.
I have the first question to both speakers. So the third speaker is missing. The first speaker is actually missing. But he would talk about infinitesimals as well. And I have a fundamental question. So what is the connection between infinitesimals and compassion?
Right. So I think in my case, maybe that was not very clear because I had a thing at the end of my talk I wanted to say, which I just didn't do. I'm a little bit of a space cadet this morning, so sorry if I missed it. The idea for the student I was talking about, I mentioned this thing about feeling like mathematics was itself was, is it possible, the way you talked on the phone when we talked 4 years ago, was that you felt like mathematics itself was not accepting you. And then you had this change when you encountered the ideas in standard analysis. You said, mathematics accepted me in, I think it was what you said. And maybe you would say it differently than this. I don't want to put words in your mouth.
Yeah, so I think this reminds me of yesterday's talk when someone was talking about was it fighting with mathematics or no, sorry, competition with mathematics?
Oh,
so
yeah, David's
talk,
yeah.
With mathematics in some sense, and you're trying to understand it, but it's very, initially very ununderstandable, and then you keep chipping away at it. And
So he was saying, it was in response to David's talk, one of the members of the audience said it's not only competition between ourselves, but competition against math, that it's sort of math is fighting you almost.
Yeah, actually my co-advisor, Professor Singh Gupta said that.
Oh, it was Amber, yeah, that's right. Amber.
So I think it was in that sense that I must have met, because I had been working with mathematics for most of my life that I could remember, in the sense that I think in around high school I started getting more fascinated by mathematics. Early on I was not so interested, in the sense that up to maybe 4th grade or so I was not very good at mathematics or really anything. But I remember there was one time in 4th grade I somehow got better marks, like actually good marks on a unit test that the teacher had conducted. And the teacher uses my answers and uses that to tell the students that, oh, anyone can get better at mathematics if you work hard. And in my mind, I was thinking that this teacher is stupid because I had not worked hard. My father had just taught me what the concepts were the day before, and so I knew what I was doing this time, unlike last times. So I was not very good at mathematics, but since my father started teaching me more, he was good at mathematics. He is good at mathematics, but not at research mathematics, of course. He has a bachelor's degree in mathematics. I eventually got better and better, and then I also had autism that was undiagnosed. I did not know about it, but I was bullied a lot. And so once I realized, once that teacher showed this, I felt that the students started bullying me less. So I correlated that studying with not being bullied. So I studied more, and eventually I was just fine at mathematics. It's not like it was something I really wanted to do for a career, but then later in high school I got exposed to more mathematics in general. Actually, somehow in high school I got exposed to mathematics from outside high school. I got a book called Applied Combinatorics by Annie Tucker, and I was reading that and I really found that fascinating. And then at that time I started then preparing for Olympiads, and I was kind of late in starting my preparation, so I only really cleared the regional Olympiad in India, but not the national one after, which is the international one. But around that time, I felt I really wanted to do mathematics for a career, And so I ended up in a bachelor's program where I could do that. But once I went there, the first year was fine, but after the first year I started getting almost failing grades in lots of mathematics subjects, right? So I somehow barely survived the bachelor's program followed by the master's program both in India. But I remembered that I still wanted to do mathematics because before all that terrible grades, I still liked something in it, so I wanted to stay in it. So I applied to PhD programs. I went to the one school that accepted me, which is LSU, and even I think LSU is not a really high-ranked university, but also not a really low-ranked university. It has a really good mathematics department, and it's a really good place for people who do not have really strong mathematical training but still really like mathematics to go there and slowly complete their PhD program. So we had a lot of students like that. Compared to them, my mathematical training in India was kind of more advanced, even though I was failing at that training. I had been exposed to like 100 different areas of mathematics in my undergrad in India. So somehow at LSE I was not challenged much by the initial courses, but still at the research level I felt inadequate. So I really could not really think about a lot of mathematics in a way that I felt I could do it, even though I was in that PhD program. I found non-standard analysis accidentally in a talk. My future other co-advisor, Karl Malberg, who was a number theorist, he has left mathematics, was giving a talk on how he used Loeb measures to work with some number theoretic problems. At the time I wanted to work with Professor Singh, who was here yesterday. And I started learning non-standard analysis though just for the sake of learning it and because I liked it. And when I went to Professor Singh, who will be my advisor, and he's like, you seem to be interested in lots of different things, so I don't think I can alone support you. You should get Carl to also be your advisor, and then maybe we can talk about some probabilistic applications of non-standard analysis. So once I started that, and once I really formally started my research portion of the PhD program, that's when I finally actually felt I could do mathematics, and I realized that the non-standard ideas that by then I had learned made sense of a lot of other previous issues I had with working with analysis or topology. A lot of concepts in analysis or topology just become simpler with the non-standard perspective, which had I seen in my undergrad or grad school, master's in India, I might have felt more comfortable with mathematics at the time.
Can I add just
Yes.
the thing I wanted to add?
I still don't know what is compassion.
Right.
Oh,
So
yeah.
what I want to say,
Yes.
what I want to add is this.
No, I was actually referring to
Right.
your...
Okay,
Yeah.
I have a question. So what is
Yeah. So the answer
compassion?
that I wanted to say to
Yes.
this is
Thank you.
that the experience that a student has in mathematics is, do I have an image that I can pursue the logical implications of, and the world of mathematics will allow me to continue to see what those things are. Like what happened with Sarah is she kept pursuing the implications of her own imagery, and she never ran into, in this interview, a perturbation, which is like some sort of inconsistency or incoherency with other things that she also thought or had images with. Because it is in fact perfectly possible to create an entire coherent world by pursuing that one image and the logical implications of that image. But she had never done that before and had never been invited to do that before and never felt like mathematics was a world in which that is a possible thing to do. Our experience of mathematics shouldn't be like that. Our experience of math is you should be able to take an idea you have and follow the implications of it and mathematically populate, like it's almost like unfolding all of the theorems and from a particular axiom or something, right? That idea, that's right. And so mathematics then is an inviting space that you can explore, and you're not going to run into a wall or a trap. Okay? But she had never experienced that before. So that's my answer, I think.
Thank you.
Can I It's not a question, it's a response. Rob, I was absolutely blown away by your talk. I haven't read your paper, I'm excited to. But just the level of, not just like what Sarah was doing, but how seriously you were taking her, and how easy, I mean, it's so easy for anyone in, any sort of mathematical position of authority to immediately point out contradictions, right? And yet the level to which you were encouraging her, following her, going on even when she was doubting herself quite reasonably based on her previous experiences with math teachers. Just that depth of taking a kid seriously.
I mean, that's compassion, right?
Yeah.
That's a form of compassion.
But I mean, it was so, I do have to say, it was like, I was just like itching to tell her about like why 0.9 repeating was like equal to 1.
Yeah.
Because I was like, this is like, there's a reason why people like think this way. And I was like, you're definitely thinking as like different, it's a different representation. I'm like, it's the same thing. But I was like, I don't want to do that. Just want her to say what she wants to say. And then eventually I did show it to her after the end of the first interview. I actually did 2 interviews with her. So that's quote that I played from her was in the second interview. Well, she said, well, now I know that it's blah, like that it's the same, but I still don't think that way. So that was after I showed her, I proved to her that 0.9 repeating equals 1. But like, she's like, I still don't, like, that's not how I think. So she then just kept telling me about her own things. Anyway, I was like, but it was in interest and tension. I was like, I have to resist trying to like stop whatever she's talking about and tell her my thing. I want to stop, it's part of it.
Yeah, tell me what was that tension like in yourself? I wonder, would a younger version of yourself have responded? Like, how is that?
This was a young.
Sure.
It was a while back. Yeah, exactly.
But tell me about the tension in yourself and how your own evolution and maybe as a younger person being
What do you mean, like
how easy or hard was it for you to resist that impulse to correct, to point out the errors?
I mean, it was easier because I knew I was like, wait, your job is to interview. Like, I was trying to figure out what people were thinking, so I was doing these interviews. So that alone was like, that I kept having to be like, no, that's what you're doing. You're not trying to teach a class. But if I was teaching, it would have been even harder.
Sure.
And so I think that's part of it, is that even when you see a student making mistakes or something and coming for office hours, and it's so easy, okay, don't do that, do this instead. It's so easy. You know what they should do. You want them to do it. Like, you feel the tension, right? And just sitting in that tension, just come in and tell them right now, like, don't do that, do this other thing instead. I'm skipping over, like, their ability to pursue themselves the implications of the thing that they're thinking. And sometimes they take 2 hours doing it, maybe you don't have 2 hours, right? But like, you are stopping or skipping an opportunity for them every time you do it. And I have to like fight my fingernails every time and go, no, don't. Just give them the space to explore that, just for a little while.
I think we heard comments of this type yesterday afternoon as well. I think both Alexander and Angel were talking about listening to what the students are saying. And I would even suggest that maybe it's not only, and it's exactly what you were saying, that, let them pursue the consequences of what they're thinking through, because either way, whichever way this evolves, is going to be a learning opportunity for them. In other words, whether they get to believe in themselves because they're making a construct, a conceptual construct that holds together, and is valid, so they don't need somebody else to tell them that, they realize it for themselves, or they recognize there's some contradiction, they put themselves in a corner, as we often do, right? But they recognize that is part of the game, that they have to learn, and there's nothing that you can tell them, nothing that you can tell them, including the canonical answer, that will be a substitute for that.
Yes. So a very quick example of this that I always come back to in my mind is a thing that I give my students when I do a class for elementary ed people. There's a puzzle that has 6 pieces in it, triangles and, trapezoid and stuff, it makes a square. And I say, now your job is to make a bigger version of this puzzle. I give them one measurement, this one's 4 centimeters, this length. I want in your new version of the puzzle that's bigger, that needs to be 7 centimeters. I give them rulers, and they split up in a group, and they have to decide how they're going to make a big version of the puzzle. And you all, so the thing you're supposed to do, the thing that works, is you measure all the lengths, and you multiply all of those lengths by 7/4 to scale them up to the right size. But of course, invariably, you can probably imagine what some of the students do. These are like people that are going to be elementary teachers, so they don't necessarily have a lot of mathematics background, and a lot of them don't think this way. They just think to measure the side lengths and then add 3 to all of them, because they go from 4 to 7 here, and that one's going to go from 2 to 5, right? And then when they try to put the puzzle together, it doesn't fit. And then they have to figure out, that's a perturbation where they encounter something. And then they have to figure out why that didn't work. And so it's so easy. I can just tell them when I do this thing at the very beginning. Make the new puzzle, here's what you do. You multiply those lengths by 7/4. It would be really fast, they'd make the puzzle be fine. But they wouldn't learn that thing because they wouldn't experience a perturbation or a problem or inconsistency that they then have to accommodate and like figure out how to accommodate.
So there's many layers. For example, according to, with the point that I was making in my talk yesterday was, I was quoting Eugene Chang, where essentially she's saying, yeah, they might learn the right answer, what to believe, but they won't know why. They won't know the moral reason why. So there's also, on top of what you're saying, it's even deeper, I think, which is the process of getting to some truth. Because there's no exhaustive set of truths that you will ever tell them, right? That you just want to empower them to be able to discover the truths for themselves that work for them.
Right, because they need to encounter a new situation down the road where they can distinguish between using additive and multiplicative thinking. But if I just tell them, do this thing, multiply by 7/4, they don't know in the new situation when that is the thing they should do. Like they haven't actually formed the schema, they're just doing a thing I told them. But if they encounter a problem with this thing, then that makes them form a schema where they differentiate between this thing worked here but not here. Like why is that? So that when they get into a new situation, they kind of know which way, what thing to do. So they're actually like building the idea when they encounter the perturbation rather than trying to remember what I told them from some other,
Which is what we encourage our students to do instead, right? We encourage them all too often, whether explicitly or implicitly, that's what they receive from us, is to remember. What did they say? What problem matches this?
Yeah, exactly. And then they have to grab something that doesn't connect. So, yeah.
Yeah, that's what I heard, struggle is part of learning process. And if you don't struggle, then you don't gain. But I want to echo that long time ago, I had a paper writing non-standard analysis. I was defining the infinite, but that small, as a sequence of numbers, and then you can always define the numbers between 0 and bigger than 0, but smaller than any real number. So, and I try to do that. That was probably 40-some years ago.
Yeah, that's one of the ways we now understand it. That's one of the constructions. You have sequences of real numbers and you can identify two sequences if they are equal and a large number.
Right, so the real number would be the sequence of the identities, then the others would be.
Yes.
And so we have 5 more minutes of discussion. Are there any other questions of the presenters?
I just say I was thinking, Ted, I connected both of your talks with Ted's comments about trust yesterday. Trust in oneself, trust in one's students, trust in mathematics.
Well, as an educator, what's your opinion on when you have a student who is, going through the process of exploring their own system that they're building up, on asking sort of questions that will lead them to a contradiction that they haven't noticed yet? When's the best time to employ those?
Yeah, that's great. I mean, this is it's funny too when people talk about like the Socratic method, like that's legitimately like what Socrates did, right? It's like pursuing the implication of a person's own thought. The word axiom originally, I think 2,500 years ago, whatever, didn't mean some sort of thing that we're going to establish as a foundational principle and then build a structure from. It was in fact an idea that you suppose in order, for the sake of the discussion that we're having right now, to pursue the implications of, and that was that. So yeah, I think that that's a perfect move, because like, what about this? Like, tell me more about that. But then allowing people to see, and that's exactly in this situation where you're multiplying by 7 fourths versus adding 3. Like, I want that to happen, so I want to like aim them down that road if possible. But you know, obviously, like there's other things that they might be able to like fill in that don't give them that. So they're actually taking the world. So it's actually like you don't want to stop them from doing that entirely. It's not like the whole thing has to collapse. I don't know. Now, part of the premise of if someone encounters a perturbation, what Piaget says is that gives them a chance to differentiate, because they can see the difference between the schema that they have that operates in certain conditions and gives them the anticipated outcome. And they now have encountered a situation where the anticipated outcome wasn't the experienced outcome. So they can differentiate between those two different types of situations. What they don't have is the successful thing that will work in that other situation. They can't just pull that out of their head. Like, how do they know to, for example, multiply by 7 fourths? So at some point you have to step in and suggest something that allows them to generalize something from some other idea that they have and that you know is going to be promising. So something, but like with Sarah, there is no end. That will never happen if she can explore her own world. She'll never run into a problem. The only issue she'll have is that her notation is bad. It doesn't give her any ability to like come up with a lot of like really deep stuff, because she's stuck with decimal notation. So at some point you'd have to come in and say like, well, let's try it. You do the same thing, but let's try this other notation.
With respect to that, I want to say something that I thought I had when you were speaking. This came to me explicitly when I was teaching for the first time in math and philosophy class for students, and I was using it for his book. And so I was Cambridge. And this is the conflation that we so inadvertently do all the time between the things we're talking about and the things we say. So, for example, in the context of number, the difference between number and numeral that Joel makes very explicit in the first chapter of his book. So I had come up with challenges for my students to engage with. For example, like I mentioned yesterday when we talked about the Goodstein sequence, which is an example of a situation where, as part of the process, you can change the place in which you describe the number, right? So that to move away from thinking that a number is what you can write, right? There's the notion of what a number is, and then there are the things that you write, right? The same with any idea in mathematics, right? But the same with any idea that we speak of anyway, right? We use words to describe ideas. The words are not the ideas. They just elicit the idea on the other person, right? Like you do some translation every time you hear something. So in math, we kind of eschew that conversation. We never are explicit about this to the students. So why should we blame them that they misconstrue what we mean with what we write? And they think the math is just simple, right? You know?
Math from philosophy of mathematics.
Yeah, so Grady keeps telling us mathematics is always mathematics.
I have a question, if I may. I was wondering if non-standard analysis is less passionate way of looking at math, and standard analysis, I wouldn't say it's dispassionate, but apassionate. And what I think the difference is that the mathematician imagines herself as a counter. I would look at the continuum as continuity, meaning that the mathematician is actually making the numeration, and when you put yourself in the process of thinking as a thinker, and you're not disembodied, but you are living by the course, then maybe you can then more easily imagine infinitesimals and things. And as far as the level of trust, you would trust your intuition. Trust to me is toleration of a certain level of uncertainty. Trust doesn't apply where there's no uncertainty. So you're always dealing with an unknown. So part of your thought process, and maybe perhaps even your notation, would have to acknowledge and name that level of uncertainty and how you deal with it.
Like to acknowledge the existence, the
Yes.
possible existence of something you can't name.
I have an idea. By the way, do we have to?
I guess let's complete. Okay, let's complete. Let him complete this.
No, we can talk.
Okay,
Talk
let's
about
not-
it. I'll talk it.
No,
Because it's
you're
10
right.
o'clock, we have another talk. But yeah,
Thank you guys for coming and for waiting for us to complete this one.